His telescope to share with you. We got one other instrument here tonight. We're going to hope that we get enough clearing in the clouds to see Saturn and some other things. But in the meantime, and if you will, thank Jack for bringing his telescope with him. Now you can't ignore these people clapping at you. Tell him to stand up and say thank you.
Thank you.
All right. Some of you may be aware of what happened this past week. How many of you are not aware of what happened this past week? So you are aware. Pluto didn't happen. We flew past it. All right? And I'm going to give you a little of the history of this. I've been talking about this the last few times I was up here, and now we finally have something to show you. We only have about 2% of what the spacecraft has gathered in data-wise, and it's going to take 16 months to get the rest of that data downlink from the spacecraft. It's only doing 30,000 miles an hour headed that way, because that's the direction it's headed. Pluto is over there. No, we cannot see it through any of these telescopes, so we're not even going to try. It won't be up high enough for us to do anything with it this evening anyway. Maybe later in the summer we'll try to take a photograph of it and show it to you, because photographically we can get it. Visually through our telescopes it's impossible. The telescopes just don't have the aperture to capture a 14th magnitude object. The guy on the left is Clyde Tombaugh. Clyde Tombaugh was not born in Kansas, but he was in Kansas in the late 1920s during the Dust Bowl, when being a farmer was not a good idea. His father was a farmer. His father's brother was a farmer. His father's brother was slightly more successful than Clyde's father was, and so Clyde got to earn a little bit of money working for his uncle. He was an avid observer of Mars and Jupiter. He built his own telescopes. His first telescope was considered by him to be a disaster. He later built his largest telescope, a 9-inch telescope. I probably have pictures of it somewhere, and if it just stays cloudy, maybe we'll drag out some more pictures. But I didn't include all of that in here. He was a very curious person. He loved observing. He was an acute observer with a telescope. And his drawings were really quite nice for someone of his age. He just graduated from high school. He knew there was no way he was going to get to go to college. He's in the middle of the Dust Bowl. Where's he got to go? He hasn't got any money. There's nothing to get him out of where he is. He's stuck. So innocently enough, he writes a letter to the director of the Lowell Observatory, Tucson, Arizona. The man's name is V.M. Slifer. And I don't know whether he was a doctor or not, but I'll just say Dr. Slifer got his letter, and Clyde wanted to know, are my pictures good enough? What is it, if anything, am I doing wrong? What can I do to improve my technique? That was an easy enough fix. They hired him. They sent him a letter back and said, we would like very much for you to come to work for us if you'd like. It won't be an easy job. They had just purchased that camera, the one on the right. That's a 13-inch astrograph. It doesn't really mean anything to anybody except that it's a special telescope that's made for taking astrophotographs. You don't really look through an eyepiece on that telescope. You put great big 13-inch glass plates in the back of it. You even have to pour the emulsion onto the plates. They didn't use film, they used glass plates. So Clyde accepted the invitation to come to work. His mother baked him some cookies, made him some sandwiches. He took what change he had in his 4 textbooks. He got on a train with a one-way ticket to Tucson, and although I hate to use the cliche, the rest is history. When he got there, you'll notice that that's a wood-slatted observatory roof. I didn't put the picture of the outside of it, but what's inside that's important here. His main job was to keep things clean, keep the darkroom clean, keep the roof swept of snow so that it wouldn't collapse under the weight, and in his spare time learn how to use that camera. So he did. In the process of using that camera, he took thousands of photographic plates. And these two plates are the discovery plates for the planet Pluto. And let me see, somewhere I got a green laser that probably doesn't work. Okay, just somewhere I have a green laser. I don't know where. So I'll walk over here and show you. The arrow right here points to a little tiny dot. And this arrow points to a little tiny dot. And if you'll notice, these three stars and these two stars are all the same. These three stars and these two stars. And the dot has moved from here past those two stars, these two stars to here. So if you sort of blink one picture and then the other, you can see that star jump back and forth. Well, I had a machine that did that. It's called a blink comparator. And what he did was he would take a series of images, one today, one a couple of days later, another one a couple of days later, of the exact same piece of sky. Then he would process those glass plates. Each of these is a glass plate, 13 inches this way, 7 to 17 inches in diagonal. And this is basically two periscopes. And it would bring both images over each other, one on top of the other. And you would turn a knob underneath, which is this knob here, just back and forth. All right, I can't remember if it was on a cam and he just kept turning it or what. Then he would look at first one picture and then the other, and then back and forth and back and forth. It always stayed right in front of him. And you would see the same field of stars. You'd start at the top, you go across, back and forth and back and forth. I don't know how long it took him. I don't know how many plates he looked. Someone said it was 16 million stars before he found this. But then with that device, he discovered that little dot moving back and forth. He went back into the library, the catalog of images, and he found an older plate from the same part of the sky, and he put it in the blink comparator, and he saw the dot further over where it should be if you calculate it based on the images that he had with these two discovery plates. So Tombaugh, at the time, believed that he had found the planet that they were looking for that was perturbing the orbits of Uranus and Neptune. And it was exactly where they predicted that it would be. And this is in 1929, early 1930, that all this is going on. I think it was March of 1930 when they finally made the announcement. And Schleifer had decided that the best thing to do was to not announce it just instantly. And of course, there were people nervous about, well, if we don't announce now, what if somebody else discovers it and we actually were the first one, blah, blah, blah. And it turned out there wasn't anybody else that found it. He was the man that's been given credit for the discovery of the planet Pluto.
Thank you.
Paul?
What?
Explain perturbing?
I'm sorry?
Explain perturbing?
Perturbing. The gravitational influence of it on other bodies in the solar system.
It caused the other two to move.
The other two to sort of do a little jog when it passed by. Pluto's orbit is 248 years. So it's not a great place to go for birthdays. If you like birthdays, go to Mercury. You have one of those every 88 days. But on Pluto, it's 248 Earth years to go around the sun one time, yes. There we go. You just had to ask the right guy. I've been looking for a reason to explode about this all day long. Pluto was described as a planet in 1930. Okay, so that's an emotional response to your question, because I feel very strongly about it staying categorized as a planet. I am one of a lucky group of people who got to meet Clyde Tombaugh. He's one of my heroes, and got to talk to him, spend a little time with him, got my picture taken, got a signed book and a signed poster that hangs on my desk. And he was a very, very interesting man. But you know what the most interesting thing about him was? In 1989, I saw him give a talk about this, the discovery of Pluto. He was a very old man in 1989 because he discovered it 59 years early. And he was in his early 20s then. Early 20s. So the thing that grabbed me was his enthusiasm, how excited he was to be able to tell a room full of people at King College up in northeast Tennessee, slam-packed like a can of sardines with people who came just to hear this minute little man tell us all about the enthusiasm that he had with the discovery. That isn't all that he did. He was, as I said, he's an avid observer. He discovered I believe it's over 200 asteroids in his time as an astronomer, and that's quite a feat. But just to hear him talk about it at that age and be that enthusiastic encouraged me to sort of follow and do the kind of thing that I do today. The two different pictures that we got up here, and I'm going to talk about the planet thing as we go along here. The picture on the left, the blue, is a photograph taken by the Hubble Space Telescope. And this was back in the very early days of Hubble, just after 90 when it went up. And they had discovered that there were some issues with the telescope having a problem, not focusing properly. They had to fix it. So you can see a huge difference between the one on the left and the images on the right after it had been fixed. But the pictures on the left, I think, are somewhere around 90. The ones on the right are 2002 and 2005. And in the 2002 photograph, there's a picture of Pluto and its large moon Charon, or Charon. You can say it either way. The pictures on the right, the two to the right in 2005, there are two additional moons that have been discovered at this point. And if you'll notice, here's how they discovered it. They took an exposure for these two in 2002, but they made the exposure much longer in pictures in 2005. That's why Pluto is so overexposed, and you don't see it as a disk like you do over here. Charon is also grossly overexposed. But in the process of doing so, these two moons called Nix and Hydra, which are the names that they became known as P2 and P3, because they were moons of Pluto, so they were the second and third moons of Pluto at that point. Two more have been found since then. They were P4 and P5, and became known as Kerberos and Styx. And so there are 5 moons of Pluto. How many moons does Earth have? 1. Name 2 planets in the solar system that don't have moons. Mercury, Venus. So Mercury and Venus don't have moons. All the other planets in the solar system do, including some of the asteroids that we've seen as we've made our way out to Jupiter and Saturn and so forth, including some objects in the Kuiper Belt, which is what some people want to call Pluto as a Kuiper Belt object, or a KBO, or a dwarf planet. Now, 8 years ago, there was a meeting, and there's just to give it all to you, there's probably 10,000 voting members of the International Astronomical Union. 2,500 of them went to the conference that year. 450 approximately voted at the end of the week to make the determination that it would be a dwarf planet instead of a planet. What prompted all of this was they had said, we need a definition for a planet. So the Blue Ribbon Committee put together, and they came up with 2 criteria. They said to be a planet, you must orbit the sun. Pluto orbits the sun. It's inclined 17 degrees to the rest of the plane, but it orbits the sun. Yes, it does come inside the orbit of Neptune, but it's never going to hit it. The other thing is that it must have pulled itself with its own gravity into a sphere, which it has done. More so than we thought, because of the approach photographs with this spacecraft New Horizons, they actually had some misgivings at first, because they saw some areas that were really, really dark, and they thought, well, this thing's not even round. That lasted about 30 minutes, because the next few pictures that came in, I mean, the improvement of pictures over days, just tens of thousands to hundreds of thousands of miles, made vast improvements in the quality of the images that were coming in. So resolution is getting better and better and better each day. And I've got an image in here, it's a GIF image, where it steps through sort of the evolution of how well we saw Pluto from the little dots in the sky that we see here to the surface covered with all kinds of interesting features that we see today. So these were early photographs of Pluto. I say early, 60 plus years after Clyde Tombaugh's picture. Clyde Tombaugh's picture was not the first picture of Pluto. Other people had taken pictures of Uranus and Neptune. They had been discovered, of course, but they'd been photographed long before they were discovered. Or, excuse me, had been seen before they were discovered. They just didn't know what they were seeing. Galileo saw Saturn and knew it was called Saturn, but he thought the rings were something that just came and went. And he quit looking at it. He could have discovered the big moon Titan if he'd stayed with it, but didn't. So this is what happens when you give up too soon in this sort of astronomy that we love so much. This is the mission subsequent to the images that you saw that was planned and put together in 5 years. Well, that's unheard of these days. It takes a lot longer to think these things through. They had a fabulous crew of people at Johns Hopkins University that won the bid for this instead of JPL. Usually you hear about JPL, Jet Propulsion Laboratory, that's who does most of these missions, but Johns Hopkins won this. And they have great people from 3 different organizations working on this mission, including some Europeans. And this is just an artist rendering of the spacecraft, which, just for your information, the gold part, which is just wrapping as a protective covering for the spacecraft, it's not much of a covering, it's more like aluminum foil. And underneath that is something about the size of a concert grand piano. So it's not very big. Concert grand is what, 8 feet long? And it's got about a 3-meter dish up on top of it that most of the communications is done through the small dish above that. That's actually called REX, Radio Experiment is what that instrument is called. And that was used for a lot of stuff when it was going past Pluto, but it also is a dish that we look at and talk to when we communicate with the spacecraft. Now, I mentioned early on that it would be 16 months before we get all the data dumped off that spacecraft. When the spacecraft flew past Pluto, and I have and you can get this online. There's a video, it's an animation that's put together that shows all the motions of the spacecraft at its close approach. And the close approach window, this is what's so cool about this mission. This is amazing stuff that's happening in our lives right now. They just kicked the doors open on the outer part of the solar system and have given us Pluto. We thought was a frozen, dead, cold world that was basically meaningless and wasn't going to be very interesting. It has been everything but that. And we only have 2% of the information back from the spacecraft. I can't wait till we get this other stuff back. It's crazy. It's driving me nuts. I stayed up all night long watching this stuff come down. So I've had a lot of sleep this week. So if I start babbling, just ignore me. There's no solar panels on it. I guess you noticed that? The reason it doesn't have solar panels is it's too far from the sun for the sun to do it any good. It can't make electricity that close to the sun. So it's got this radioisotope thermoelectric generator, which has plutonium dioxide, which glows red. And it's not something you hold in your hand.
That's
it's
appropriate.
radioactive, and it produces a lot of heat as it decays. That heat is in close proximity to a whole bunch of thermocouples on a tube, and they convert the heat to electricity. And so that's where it gets its power. It's got plenty of power for years to come. It didn't use just a whole lot of power in the flyby of Pluto, but that was the main part of the mission. So now the extended part of the mission is to go on to the Kuiper Belt and try and find some objects out there, which the Hubble Space Telescope has been looking for. So this team is working in conjunction with the Hubble Space Telescope people, and they have defined, I think, 3 or 4 objects in the Kuiper Belt for the spacecraft to look specifically for. It has a long-range camera. It has a spectrometer. It has a camera for close-up imagery. There's 7 instruments on the spacecraft. All of those instruments, during that flyby, it was an 8-minute window. It was traveling 30,000 miles an hour. It had to fly through a box in the sky 60 miles by 90 miles. There was a smaller box inside that, and it almost passed through the center of the smaller box. That's how close they were when they flew where they intended to in this mission. That's amazing. 9.5 years, 3 billion miles, and sink a hole in one? Really? That's stunning. But if it strikes you I'm just a little bit excited about this, don't panic. So that's an artist's conception of Pluto and Charon. Yeah. Just before it flew past Pluto, it looked up and it took that picture. I thought it wasn't looking in another direction. The North Pole is this point right here of Pluto. So figure that in your head here where exactly that is about here. They saw this band of stuff, appropriately called complex patterns. There's a polygonal feature right here. And interestingly enough, on the bottom of the ocean floor, in several places on our world, there are these polygonal shapes. On the surface of Mars, there are these shapes, and they believe to be associated, at least in the case of Mars and this, it has something to do with expansion and contraction of the ground because of the temperature extremes. Now, if you were to go to Pluto and stand on the surface, you wouldn't be able to blink but one time because it's 400 degrees below zero and your eyelids would freeze shut. So it's extremely cold, but it has seasons. Even at the great distance it is, it's having seasons right now. We're looking at North Polar, I believe, winter in these images. So this was what's called the far side of Pluto. Just like we have a far side of the moon. And this mission, I believe, if I understand it correctly, they were able to image all of the planet, but not all in the same resolution. So this is a much lower resolution than the flyby resolution, because this is, I think, 740 million miles away, I think is the correct statement to make, when they took that photograph. This is the portrait. This is the picture of Pluto. This is a high resolution image after it flew past the far side is out of sight now. And actually, everybody sees the heart, right? We've had a lot of fun with that. If you follow it on Facebook, you will have seen sketches of Pluto and Snoopy and all of that stuff made out of that heart. It has been unofficially named by the New Horizons team and the principal investigator. It's been unofficially named Tombaugh Regio. Which is, if they plains-like area, they know more about it now. They've got a high-resolution picture of that. So there are already 3 unofficial names being kicked around. I don't know that I'll remember the third one. I know the second one. But you see dark features and light features. You see different shapes and contours. But it is spherical. So for me to try and stand here and tell you that anybody knows what anything is right now would be foolish, because no one does, including the experts. Nobody wants to get too far ahead of this thing and make idiotic remarks about it and say, well, it's this or it's that. There's a lot of could-be's and maybes right now. And it'll be that way for some time to come until more data comes in from the other instruments. So a lot of what we're looking at are images that were sent down so that we could, one, know that the spacecraft successfully flew past it. There was a lot of breath holding. If you imagine my fist is Pluto and its moons are like this in this orbit, they flew through that system like this at an angle. Before they got there, they took thousands of images because they were looking for dust particles. Now, you hit a grain of sand at 30,000 miles an hour, you just wrecked your spacecraft. And that's what they were afraid of would happen here. As it is, these are the 2 highest resolution pictures that we've seen so far. If you go back to the heart shape, down in the lower right side, that's where this is, right on the limb. And the most interesting 2 things in this to me are what appears to be some kind of a ripple in the surface right here. You can see these arcs. But then, when you blow this thing up and you put this, like on our planetarium dome that you see, I I looked at this last night. This thing just leaks off the screen after this groove right through here. There's no telling what caused that. What kind of life has Pluto had? Why is it even alive? Why are there mountains of ice? Those mountains are 11,000 feet tall. Now, if you compare those to the Smokies, how many of you from around here? Few people from around here. Where are the rest of you from? That's good. I drink on whatever it is, it's cold. The mountains are made of water ice. It can't be made of anything else because anything else that's lighter wouldn't support its own weight, so it has to be water ice. Over on the left, that's up in the upper left part of the heart. It's a plains region, and it's called Sputnik Planum. Sputnik was the first satellite to orbit the Earth, and I just, for whatever reason, I can't remember what the third thing was. It was another first. It was the name of the Sherpa guide that went with Sir Edmund Hillary to Mount Everest. Yes, that's what it was. I don't remember his name though.
Norgay Tenzing.
What he said.
No, that's the other way. Tenzing Norgay.
Okay, fight about it later.
No fight about it. That's it.
Max says that, and that's probably right. Did he play football?
For UT?
No, he didn't play football.
Not for UT. Yeah, probably not. No. This is the moon, Charon, and that's a close-up of a small area you see inset on the right. This is what they were calling a mountain and a moat. And the first thing that came to my mind, if anything ever does come to my mind, was this looks like a mountain that was so big and so massive that the surface beneath it couldn't support its weight and it's sinking. That's what came to me. I'm probably completely wrong. That's okay. We're here to speculate. This is the North Polar cap of Charon, and it's got all this dark material scattered all over. That's another mystery. But look at all the textures and all the features, and this was supposed to be just a couple of balls of ice out on the edge of the solar system. These surfaces are 100 million years old. That means that it's active. This thing, everybody thought these things should have been frozen to the core, but they're not. And so the principal investigator for New Horizons' name is Alan Stern. And Alan Stern says he thinks that the solar system left the best for last. And I think he's right. I have always referred to this as the first mission to the last planet. Okay, let's kick that planet thing around a little bit. So these guys where was the meeting?
Europe, where was it?
Wherever it was. It's over here. These guys called dynamicists jumped up out of their chairs and said, that can't be the definition for a planet. This thing hasn't cleared its orbit of debris. That means that it's massive enough that it has swept the debris out of its orbit. It's either collected it up, it's crashed onto the surface, or it's pushed it out gravitationally. Okay, that's fine. Now let's think about that for just a second. If you think about that for just a second, it shouldn't take more than a second. Whether you are an astrophysicist, a dishwasher, it shouldn't make any difference. All it should take is a second. How many planets are in the solar system by their definition? 8. Huh?
9.
By their definition. 8. They have to have cleared all of their orbits of debris.
0.
2. Mercury and Venus. They neither have moons, they don't have Trojan asteroids in front of or behind them. Earth has a Trojan asteroid 21 million miles out in front of it in a stable orbit. It leads us around the solar system. It's stable for 100 years at least. We have over 10,000 near-Earth objects that we're concerned with. 4,000 of those are called potentially hazardous asteroids. If you lived in Chelyabinsk, Russia 3 years ago, you know all about this because you got rained on by an asteroid that exploded in the sky over your head and did millions of dollars worth of damage and hurt 15 people. 1,500 people. Not 15. 15 doesn't sound near as good as 1,500. But seriously, 1,500 people were hurt not by debris falling from the sky, but glass and debris falling off of buildings when the shock wave hit the ground, fortunately at a very, very, very shallow angle, or it could have been a whole lot more devastating than it was. So the dynamicists won the toss of the coin. They won the vote. And so they said, okay, there are 8 classical planets in the solar system. Pluto, Haumea, Makemake, and half a dozen other objects. They'll be dwarf planets. Well, let's think about this just a second. Put your hand down. I'll call on you again. Let's think about this for just a second. When you take the solar system apart, we put it into several different categories. Actually, 3. Mercury, Venus, Earth, and Mars we call what kinds of planets? What? Terrestrial. It's called terrestrial planets. And then there's Jupiter and Saturn. What are they? Gas giants. And then Uranus and Neptune, they're still gas giants, but they've been parsed out to be what are called ice giants because they have these big, slushy, icy sections in them beneath the surface. So they call them ice giants. And then we get to the realm of the ice world, and those are what have become known as the dwarf planets. But there's a hitch in this get along. Ceres is a main belt asteroid, and it's one of the dwarf planets. So it doesn't even fit their own dynamic criteria for this stuff. It's not one of those. It's not in that third group of planets out there. It's in the middle of the solar system, for crying out loud. So when you think about what we have to call these things, we needed to do a better job of defining planets. All we talked about was, well, what are planets in our solar system? What we're finding now is that there are planets probably orbiting almost every star out there. So the thought is that there are more planets than there are stars in the universe, certainly in our galaxy. Now, the argument was made that, well, you can't remember. What are we going to do with 12? How are we going to remember 12 planets? Somebody at that meeting stood up and said, table of the elements. How many elements on the table of the elements? 117 now? Something like that? Well, who remembers those? Kids fresh out of high school remember those. So if you got to remember 12 planets, and that's too hard for you, well, you know what? I can't remember fucking anything. Well, for my money, Pluto is a planet with 5 moons. And all of those moons will probably fall off of Pluto. Here's the pair, Pluto and Charon. And they're in the picture, the close-up shot of the mountainous region that you saw down here in this plain area that we looked at, there are no craters. There are no craters. And when you look at Charon, and the picture of the cutout here, look at, there's craters all over the place. So there's impact going on in that part of the solar system. Question is, how did Charon get so crazy? This is a false color image. I have no idea what it means. They did this, and I think it's simply to define different characteristics about the surface features, whether it's chemical, I don't know. I'm not going to pretend to know. I went backwards. Yeah, okay. This is the evolution in how we've seen Pluto. From the first pixelated image from a digital camera to the last high-resolution image of the mountains on Pluto. So I will tell you that one, and that one, and that one. First 4 images are Hubble Space Telescope images. Everything else is the LORRI camera on board the spacecraft. And as you get closer and closer, the resolution improves. There's a lot more of that high-resolution stuff to be downloaded, but it takes a long time. It takes 4 hours for the data to get here, and that timeline is getting longer. The farther away it gets from us, the longer it takes for the data to get here. So they're using 3 dishes at any one time, the Deep Space Network, to receive that data, and we're talking about millions of billions of a watt of energy. Way less power than your watch will take. And I think the transmitter on board the spacecraft is only like 40 watts. At 3 billion miles away, that translates to not a lot of juice. So what was your other question? Over there that had your hand up. Would you keep it? What'd you do with it? I'd sell it. Okay, here's a comparison of Pluto and Charon to some features on the Earth. Pluto is just shy of 1,500 miles in diameter, and Charon is half the size of Pluto. Now, here's something that's really interesting. If you compare all the planets in the solar system, and we'll just call everything planets, okay, to their satellites, when it comes to which planet has the largest satellite to parent body, it's Pluto. Because Pluto's moon is half the diameter of Pluto. Earth's moon is number 2. It's 1/4 the diameter of the Earth. So we got something in common with Pluto. We share the distinction of having the 2 largest moons in the solar system when compared to the parent body. Now Jupiter's moon, Ganymede, is the largest moon in the solar system. It's bigger than all of those, bigger than Pluto. In fact, the moon's bigger than Pluto. Because it's, as I said, it's 1/4 the size of the Earth. So, that's the last slide. Does anybody have any questions? Is it something I left out? Cover?
It's pretty dark. I got a lighter though.
No, we don't need a lighter.
I got a question.
Okay.
Are there objects in the Kuiper Belt larger than Pluto?
They don't know that.
They haven't found one yet?
Have not found one yet. Everything they found is smaller than Pluto. Eris was to separate one from all the rest. Eris, when they first discovered it, they believed that Eris was bigger than Pluto. It is more massive than Pluto. It's made of denser stuff, but it is actually smaller in diameter than Pluto. They know that now for a fact, because we've flown past Pluto, and every time they image Eris, they check it against all the data they got plus Pluto, and now we know it's smaller than Pluto.
Does scale matter much?
You would weigh more on Eris than you would on Pluto.
Does scale or volume, do either of those really matter when it comes to defining the planet?
I have not heard that said. I've never heard that said. I don't think that should enter into it. I like the idea of it being spherical and having to orbit the sun. I don't like the other nonsense, because I think that is nonsense. Jupiter has over 4,000 Trojan asteroids in front of it.
So it's following?
It's in front of it. It's leading it around its orbit around the sun. It's got another several thousand behind it. Saturn has all kinds of stuff. Uranus and Neptune, no doubt, they're out in the Kuiper Belt, for crying out loud. Well, Neptune's at the edge of it. So there's all kinds of stuff all over the solar. The solar system is not a clean place. It's not free of debris. The Earth collects 50 or 100 tons of debris every single day. Just debris that's up there. I'm not talking about man-made satellites. I'm talking about space junk.
Is there any sort of benefit to us? You know, because I know it was a real crapshoot, hoping this thing gets there, lands, and works.
Well, it's not landed on anything. It's not gonna.
What's the benefit, though, of launching something out that far? Other than knowledge, obviously.
Well, knowledge. That's the big thing, and understanding more about our solar system and how it formed. This, as I said early on, was something that just kicked the doors open on the outer solar system. You could say close the doors on the solar system. You could say anything you want. It doesn't make a difference what you call it. We can get all tangled up in names and titles and all that kind of stuff, and all that's meaningless. What means something is that we are naturally curious. When we stop being curious, we stagnate. So we do this because we want to know more about how the solar system formed. What role did Pluto, if any, play in the formation of the early solar system? There are people astronomers, who have run all kinds of computer simulations that show that the early solar system was very chaotic, that the planets where they are today is not where they were early on. Pluto may have been early on close into the sun, closer than it is now.
What do you think will happen if science debunks faith and they can actually prove
I'm not interested in that argument. Science and faith are two completely different things. That's not something I discuss.
Good point.
We're talking about the difference between, in my estimation, and this is all I'll say on the subject, Your definition of truth is different than the person's definition of truth next to you. I'm interested in facts. Facts and truth are very often different things. So you can have that debate any number of ways, but that's not the debate that interests me. The debate that interests me is how the solar system got to be the way it is. And we have to go, you know, Christopher Columbus sailed over the edge of the earth as far as some people were concerned. I don't know how many flat earthers are here right now, but I suspect none. Because we're standing here rotating on our axis. I can't see Polaris right now, but that's okay. It's right up there. And we're rotating on our axis. You know how fast you're going right now? You're going 67,000 miles per hour. We're rotating on our axis of between 800 and 1,000 miles an hour, and it takes us a whole year to go around the sun one time. And in order to do that, we have to go 66,000 miles per hour. So we're going somewhere between 66 and 67,000 miles per hour. And as we rotate on our axis, stars appear in the eastern sky, rise up, go across the sky, and set in the west. Anybody got a laser? Green? No? Okay. I don't know what I did with mine. But right up there, straight up in those trees right over there, the brightest yellowish dot is Saturn. Saturn stays in the same constellation for 2 years. It takes it that long to move in its orbit around the sun. So next year about this time, we're going to see it about in that same part of the sky. We'll have moved, but
Avert your eyes.
Mars, Venus, all the ones closer to the sun, they move much more quickly across the sky. We see them in different places. Jupiter's the same way. Jupiter goes in one constellation a year. Saturn, one constellation every 2 years. And the further out you go, the longer it takes to see them go across the sky. So those are things that we see, they're measurable. We can calculate their positions. We can calculate eclipses. We can calculate meteor showers. If you're looking for a meteor shower, stay tuned next month. On the morning of the 12th and 13th of August, best meteor shower of the year is the Perseid meteor shower. These are things that by observation, we have learned how to calculate when they will recur. So that's why we learn. That's why we continue to ask questions. Science isn't so much about, yeah, you're looking for answers to questions, but the more questions you get answered, the more questions get asked. And that's what makes it so fun. It's just like this Pluto thing. Who knew? You know, we're all sitting around waiting, well, it's going to be this boring, good, be all frozen. No, it wasn't. It's alive. Something's going on out there. What's that internal mechanism that's creating the heat that causes the ice to be molten enough for ridges and mountains to form? That's insane. But it's new. It was not expected. So that's what gets me excited. You couldn't tell that, I'm sure. Does that help?
I think of the money we launch like there's some long-term payoff to it other than knowledge. Like there's a reason we launch billions after billions into space. And knowledge, it is cool, but until I see a Martian, I'm going to be like, that was a waste of another $1 billion.
Well, what good would it do you to see a Martian?
It wouldn't do me any good, but seeing Pluto does the same as seeing a Martian.
I think, as I said, I think the fascinating thing is that it was completely unpredictable. Had no idea it was going to be what we've seen so far. And as I said, we've only seen 2% of the data. 2%. We got 16 months to uncover the rest of it. And then it'll be years before it's deciphered. And this was not the most expensive mission ever launched. This was a cheap mission.
What's cheap in a relative sense?
A few $100 million.
And that is insane. It's incredible.
No, not really when you consider what they just spent on the last aircraft carrier.
Well, yeah, no.
$12 billion.
That thing's going to be in the waters for a long time.
Yeah, but they had to build a carrier fleet to go with it. So it's not just one ship.
Lowly skill. I'm just busting up.
You know, an F-35 fighter costs $151 million without the engine.
But it does something.
Not right now, it doesn't. You can't get them off the ground. I've been in the Civil Air Patrol for 20 years. You want to talk about that stuff, talk about it after we start looking through telescopes.
You're heads and shoulders above me.
No. I'm going to put this telescope, well, I'm going to point it at Saturn. I'm not